applications. Okay, you'll kind of see where some of this is used. All right, so what we're going to do in 6.6 to start with is we're going to solve a logarithmic equation. Okay, so that just means you have an equation that has a logarithm in it, and you're going to have to find that unknown x. Okay, it's pretty important that you try these. These are kind of the general steps. Try to get your log isolated on one side, and it's pretty important that that log is isolated. And what I mean by that is you want to just have like log base 2 of something equals something. You don't want any number in front. You don't want it added or anything like that. You just want log of something like that. Okay? And you're going to use properties like we just got through doing. Generally, you're going to write an exponential form, and then it's real important on a lot of these problems to check your solution, because sometimes they don't work. Sometimes you have to throw a solution out. We call that an extraneous solution. All right, so we'll start with the simplest case. If you look at this log, is that log isolated? Is there anything on that side of the equation except a log? No, there's nothing in front, so that means we're good there. Now we're going to write this in exponential form. How do you write that in exponential form? 2 to the third equals x plus 3. There you go. Okay, now you solved that equation. That's the equation you know how to solve. So it would be 8 equals x plus 3. You can do that in your head. You don't have to show that step. That's easy enough to do in your head. So you get x equals 5. Okay? All right, now let's go ahead and check this. So anytime that you check any equation, you know, general rule of thumb on this is you want to go back to the very beginning and you just want to plug in your answer. Okay, so let's see how this works. And this is how you understand what you just did. Okay, so what we're going to do is this would be log base 2 of 5 plus 3. Okay, so that is log base 2 of 8. Okay, what power of 2 is 8? 3. So that's equal to 3, isn't it? Okay, and that's what it's supposed to be, so it checks out. So you can plug your answer into the original equation and see if it works or not. There's going to be times when it does not. In that case, you either check your work or you may be what we call an extraneous solution. Okay, that's kind of the simplest case like that. Okay, the next one is what you want to do on this one. This one's a little bit different. Is anytime you have a log on both sides and the two logs are isolated, then you can just remove the log. Now, you're not dividing by a log or anything like that. Sometimes I'll see students do stuff like this, and that is nonsense. Okay, a log by itself is like a log, okay, like firewood or something. It's got to be a log of something, okay, so you can't just do stuff like that. What you do is you take the logs off. Okay, you can take a log of both sides of an equation, but you can also remove it. Okay, so basically what you get is that equation, and then you can solve that equation. Okay, so that would just be x plus 3 equals 5x minus 2. However you want to do that. Okay, I'm just going to get all of my x's on one side. I'm going to move the x there, and I'm going to move the negative 2 there. I'm going to choose to do it that way. So I have 3 plus 2. I add 2 to both sides. Then I have 5x minus x. I subtract x from both sides. So that's going to give 5 equals 4x. Divide by 4. And on that, we're going to get x is equal to 5 over 4 like that. Okay? Well, that's it. All right? That's what you want to do on that is just remove the logs. I'm not going to check all of these. I'm going to bypass the checking on this one. You could plug the 5/4 in, and basically both sides would turn out to be exactly the same. Okay? You okay? Or stretching over there? Or, okay? All right. You can stretch. Okay? Just make sure you don't have a question. Everybody good so far? Okay? All right. Let's take a look at this one then. All right, now this one is where you have to use properties of logs. So notice on this you have a plus sign. So how do you put those two logs into one log? You write it as a product, right? Okay, good. So what you want to do is write this as log of 3 times x minus 24. Okay. Oh, hold on. That's a base 3. I'm not seeing. Sometimes on my computer the bases don't look good to me. So that would be log base 3 of x times x minus 24 is equal to 4. Okay? That log is isolated, so now exponential form. So take it to exponential form. So that would be 3 to the 4th is equal to x times x minus 24. Okay, so you got to use a property sometimes to solve these equations. Okay, if you work out 3 to the 4th, that's going to be 81. I'm going to multiply this out to get x to the 2nd minus 24x like that. Okay, now how do you solve that kind of equation? You've seen that lots of times this semester. It's a quadratic equation. What do? One side equals 0, right? And try to factor. Hopefully it'll factor. So we're going to move that over like that. So that's going to be 0 equals x squared minus 24x and minus 81 like that. So this one does factor, I'm pretty sure. If it didn't, you'd go a quadratic formula. So what we'll do on this is the factoring on this. You're looking for two numbers that are going to multiply to give negative 81. And those two numbers have to, I think of it as they have to be 24 apart. Does anybody know what that is off the top of their head? Sometimes they're fat, you can get them fast, sometimes you can't. What numbers go into 81? 9 does, 9 times 9. 3 does. Let's see. You can always try this if you have trouble figuring this out. You can start by doing a factor tree. That's 9 times 9. 9 is 3 times 3. Now you got to put those 3's back together in a kind of a smart way. Any idea? 3 times 3 is 9. What's 3 times 3 times 3? 27. There you go. That's the magic number. See, that really gives 27 and 3. And 27 and 3 are 24 apart, right? So this is going to factor like this. We're going to say x and x, 27 and 3. And then figure out the signs. Make sure your signs are right. So that middle term is 27x. That outer term is 3x. You want that to be negative 24x. So that means you're going to have a minus 27 and a plus 3 like that. Okay? And factoring sometimes, don't forget about factor trees. Sometimes you have to play with the numbers a little bit to get it to factor. You could go the quadratic formula and bypass that, and you would get the answers anyway. Okay, so what does it look like the two answers to this problem are? And it's the two potential answers. What do you think? X equals 27 and x equals negative 3, right? Okay, now don't move on. You want to check both of these answers and make sure they're right. Okay, so the first thing I'm going to do on this is I'm going to start with the x equals 27 and plug it in. Okay, we're going to plug it into the original equation. So that would be log base 3 of 27 plus log base 3 of 27 minus 24. We're going to work that out without a calculator or anything and see if that's 4. Okay? Okay, tell me what the log base 3 of 27 is. What do you raise 3 to give you 27? 3, good, that's 3. Okay, this next one is log base 3 of 3. What's the log base 3 of 3? 1, because 3 to the first is 3. 3 plus 1 is 4. That's good. So that's definitely an answer to the problem. Okay? All right, you work the logs out. Now let's go with the negative 3. Okay, we're going to plug it into the original equation. So that would be log base 3 of negative 3 plus log base 3 of negative 3 minus 24. All right, there's a problem with that. Does anybody know what that problem is? It doesn't work. I already know why. Do you? There you go, good. Okay, you can't take a log of a negative number. So that right there is undefined. And that's what you got to check for. It's not that that's a negative answer, it's that when you check it, you're taking a log of a negative number. So you got to throw it out. Okay, remember, you can only take a log of a positive number. Okay, so that has to be thrown out. That one is extraneous, so we call that an extraneous solution. So the only answer to this problem is 27. We verified that's right. That happens on this type of problem frequently. Okay, there's even times when you get no solution. Maybe it's possible that both of those solutions don't work. Okay, so that's the idea. Okay? All right, is everybody okay with what I just did? Okay. All right. Let's see. Let's go to, I'm going to do one like this now. Okay, so this one right here, what you want to try to do is you want to try to get all of your logs on one side. Log of something just equals a number. Okay, that's what you want to try to do. If you have logs on both sides of the equations, a lot of times it's a good idea to get them on one side. So what I'm going to do is move that log there, leaving the 3 where it is. So I would have log base 2 of x plus 1, and then minus log base 2 of x minus 2 is equal to 3. Okay, like that. Okay? All right, now how do you put those 2 logs into 1 log based on the properties we learned? You do a different, what'd you say? What'd you say?
It's the fraction.
Yeah, the fraction one, okay. I thought I heard difference, for which the difference goes into the fraction thing, right. The quotient, okay. So this would go like this. We'd say log base 2 of x plus 1 over x minus 2 is equal to 3. Okay, now you're going to write this in exponential form. That's kind of the typical thing you do. So exponential form, you'd say 2 to the third is equal to x plus 1 over x minus 2, like that. Okay, 2 to the third is 8. So we would have this. Now we got to solve this equation. And when you solve these equations, all kinds of things can pop up. That's an equation with a fraction. So what's the best approach to finishing this problem? What's next? Multiply by x minus 2. You want to get rid of the fraction, right? So don't forget, if you have an equation with a fraction in it, get rid of the fraction. So both sides have to be multiplied by x minus 2. Okay? So what I'll have here then, I'm going to bring this up here so I have a little bit more room. I'll have 8x minus 16 on the left side. On the right side, I'll have x plus 1, like that. So that's the equation we want to solve. I'm going to get all my x's on the left, all of my constants on the right. So I have 8x minus x equals 1 plus 16. So that is 7x equals 17. And if you divide both sides by 7, you'll get an answer to that problem. Now, as far as checking, let me explain what you want to do at a minimum, okay, without going through and checking every detail. I mean, there's a lot of things you could do. You could plug that in and work it out. But here's mainly what you want to do. Plug it in and make sure that you're not doing a log of a negative number. So if you put 17 over 7 plus 1, that's positive, right? That's okay. That's good. If you go here, 17 over 7 minus 2 is also okay. 17 over 7 is a little bit bigger than 2. So that's positive. You see what I mean? So that's good. That's good. At a minimum, that's what you want to do. You don't have to go through all the details necessarily. You're just looking to make sure that you're not doing a log of a negative. Does that make sense to everybody? Okay, so double check that. Okay, so I'm going to have you do the next 2 problems, and go ahead and take a few minutes to do those. I'm going to shut this off just a second and see if you can process through how to do those, okay? And then we're going to begin to look at 5 through 7. I want you to work all 3 of those out. Then we go to exponential equations. And you want to try to check these too. Okay, you want to go through the details of checking that. It's pretty important because you probably will have in one of these problems somewhere an extraneous solution. Well, let me see. What'd you get on number 5? 12. 12's good. Did you check it? Students never check these things, okay? You should, okay? You need to do that, okay? How about number 6? 5 was, did you get 2 answers? What were the 2 answers to start with? 5 and -7. Now, which one didn't work? -7, okay? And it's because if you plug it in, you'd be doing a log of a negative number. Okay, you got the 7 yet? Okay. I'll give you another minute to try to wrap that up and see. So if you got the first 2, then we're okay. I'm going to go ahead and plug this thing back up here. If you're not done with 7, go ahead and finish it up. But there's what I did on number 5. Number 5 is the simplest one, just writing that in exponential form. And then the second one is where you got to do the quadratic equation. You end up having something that factors, and that one's extraneous. And really all you got to do is just, if you look at that -7, see that would be -7 plus 4, which is negative. You can't do a log of a negative number. You can kind of do that in your head. The 5's okay. Okay, you got positive numbers. I didn't go through the details of checking the 5, but you can. Okay? All right, so we got that. Has anybody got 7? An answer? I got a fraction.
I got 5/7.
You got what?
5/7.
I can't remember what I got. Yeah, I got 5/7 too. Okay, good. Okay. Let me look at the 5 and 6. Do you guys have any questions about 5 and 6 before I look at number 7? Does that look okay? Okay. All right. Now, this one right here is just what you're going to do with this one is you want to have, let's see, right? You want to move the 2 over there. So you want to have all your logs together and your constants there. Then you put this together, since it's a subtraction, you put it together as log of a fraction. 4 minus 2 is 2. So that's the whole key to starting the problem, to get a log equals a number. Then do exponential form, so you do 3 to the second equals 2x plus 5 over x. I have a fraction I want to get rid of, so I multiply by x. Then I have 2x plus 5 is 9x. Okay, and then from there it's pretty easy to solve. Now what I do on this one, without going through the details of checking, okay, if you do 5/7 there, your log of 5/7 is cool, right? Okay, how about this? 2 times 5/7 plus 5 is a positive number, so you're also good. At a minimum, that's what you got to check. Make sure that you don't have any answer that causes you to do a log of a negative number. Okay, does that look okay to everybody? Okay, all right, so that's what you kind of get into in your log equations. You're going to put those together like this. The next thing we're going to begin to look at is exponential equations. We're going to review, first of all, the type I already taught you how to do in a previous section. Then we're going to get into the use of logarithms here, okay? All right, so that one's 5/7. Okay, these right here, we're going to just do these the way I already taught you, just sort of as a quick review on this, okay? So the idea with this is you can write these things as powers of 2. So you could change that 4 to 2 to the second, then that whole thing would be to the x power, okay? And you can also do 2 to the 6th is 64. Okay, I designed those problems so the 4 and 64 can be written as the power of the same number, okay? And then what do you do with these exponents, 2 and x? Multiply them, okay? So what you're going to do is you would get 2 to the 2x equals 2 to the 6, okay? And then what we talk, sometimes I can't talk and write at the same time, so that's equal to 2 to the 6. So what we talked about before was if the bases are the same, what do you know about the exponents? They got to be the same also. They can't be anything else. So you would have 2x equals 6. Then if you divide by 2, you would get x equals 3. So that's the answer to the problem, okay? Now this problem I think you could probably do in your head anyway. All it is 4 to the 3rd is 64. So if you can do something in your head, do it in your head. Okay, but that's the methodology we went through, I think it was like sometime last week when we were doing this. This one's the same way. You're going to write this as 2 to the 1 plus 2x. What are you going to do with the 8? 2 to the 3rd, good. Same idea. If the bases are the same, then so are the exponents. So what you would do is just set those exponents equal to each other and then solve the equation. So you'd have 1 plus 2x equals 3. I'm going to move the 1 to this side to get 2x equals 3 minus 1. So that's 2x equals 2. So x is equal to 1. Okay? And then for checking on this, you would just do 2 to the 1 plus 2 times 1. Just replace x with 1. That would be 2 to the 1 plus 2. That's 2 to the third. So that's equal to 8. So those two are really simple to go through and check and verify. So I want to review that to show you why the next group of exponential equations have to be done differently. Those are kind of a special case where you can make those bases the same, okay? But what we're going to do now is when we go down and look at this problem, where you still have the same structure, you have 3 to a power equals 19. You can't write 19 as a power of 3. I mean, you can, but it wouldn't be something you can do up here. Okay, you would end up having 3 to some probably irrational number or something. So what you have to do on this is you have to take a little bit of different approach to this. And the key thing that you're going to do is you're going to do logs of both sides of the equation. So that's kind of the key thing, is you're going to do a logarithm of both sides. Now you can do a log base 10 or a base e. It won't make any difference because you're going to have to get an estimated answer on this on your calculator anyway. So step 1, what I'm going to have you do is you're just going to do, let's do the ln on this problem. You can do ln or log, it doesn't make any difference. We're going to do the ln of 3 to the x minus 1, and that's going to be equal to ln of 19 like that, okay? Now, what we learned earlier, this is real important, what can you do with that x minus 1? You can bring it down, okay? That's why this works so well. So what you would have is x minus 1 times ln 3 is equal to ln of 19. Now we're going to try to get an exact answer, and then we're going to try to get an approximate answer with our calculator and check it with our calculator, okay? So what would happen with this then is you want to get x by itself. So what you could do is you could divide both sides of this equation by ln of 3, okay? And then that would just give you x minus 1 equals ln of 19 over ln of 3. Don't do anything with ln of 19 over ln of 3. All you could do is just do something on your calculator. Then what we're going to do is add 1 to both sides. You can do that in your head, just kind of move the 1. So we would have x equals 1 plus ln 19 over ln 3. Now that right there is the exact answer to the problem. Okay, you're going to find that ln of 19 and ln 3 are irrational numbers, kind of like pi. The decimals continue forever without a pattern, okay? So what we're going to do is get our calculator, and then we're going to go ahead and just get a decimal on this, okay? Now again, you could do the log. If you did the log, you get exactly the same answer. So I'm going to do this in one step. 1 plus ln of 19, close parentheses, and then divide by ln of 3, and then we'll round this to like 2 decimals, okay? So I'm getting this. So we're going to say x is approximately equal to about 3.7, okay? So we got an exact answer and we've got an approximate answer like that, okay? All right, is everybody okay with what I did with that problem? Okay, you got to use logarithms to solve that type of exponential equation. Now we're going to check this on the calculator. So what we're going to do is just going to do 3, and then that exponent is going to be 3.7 minus 1. Okay, we're going to plug that in. So that would just be 3 to the 2.7. And let's see how close to 19 we get on the calculator. That's what you'd have to do. So I'm going to go 3 raised to the 2.7 power. If I do that, pretty close, okay? You're off a little bit because we rounded that to several decimals. So you would have, that would be about 19.4, so that's off a little bit. But the idea is the more decimals you would use on that, the greater the accuracy would be. Okay, so that's the idea. This is the exact answer. If you plugged that in and checked on your calculator, it'd be perfect. Okay, so that's the idea. All right. Okay, so typically what you're going to do on this is do logarithms of both sides in order, and then estimate the answer with a decimal. Okay, let's go to the next page here. Okay. All right, so this one, same idea. Now, if you have e as your base, then you want to do an ln. If you had 10 as your base, you would probably want to do a log. Okay, it's just better to do it that way. So in this case, although you could use a base 10 log on your calculator, it's advantageous to not do that. So what we're going to do is take the ln of both sides, just like the last equation. So we have ln of e to the x plus 3 is equal to ln of 6. We're going to get an exact answer, then we're going to get an approximate answer. Okay, same idea. What do you do with the x plus 3? Bring it down. Okay, so you're going to have x plus 3 times ln of e equals ln of 6. Okay, this is going to pop up so much you want to know it. What is ln of e? It's 1, because e to the first is e. Okay, so that's going to become 1, so you're going to have x plus 3 times 1 equals ln of 6. So that's x plus 3 equals ln of 6 like that. Okay, now what we want to do with this is you can move the 3, subtract 3 from both sides. The best way to write your answer would be x equals negative 3 plus ln of 6. Okay, now you can also write this as ln 6 minus 3. I don't usually like students to do that way, because then a lot of times I see students give me the answer ln of 3, which is wrong. So it's better to do negative 3 plus ln 6. You see what I mean by that? Sometimes if you write it this way, you're thinking that the 6 and the 3 go together, and they don't. Okay, so this would be the exact answer of the problem. Now, if we go through and get the approximate answer on the calculator, we just get our calculator out, and then we would do this. So we just go negative 3 plus ln of 6, and round it to like 2 decimals. So that would be x is approximately negative 1.21. That would be your approximate answer of that problem. Okay? And then what you can do is you can check this real quick on your calculator. You can go e, you can do your second ln to get e, and then you can put your answer in, negative 1.21 plus 3. I mean, you can go ahead and just put it in like that in one step, and notice if I do that, well, it's close to 6. It's 5.98, so you can tell that we're close. It's because we rounded, that's why it's not perfect, okay? All right, is everybody solid with what I just did? Okay, so what you're looking for is a number. Your exponent is, your unknown is in the exponent, and then you're working with logs of both sides, okay? All right, so let's see. What I want you to do on this one is, this one I want you to use like an ln of both sides, okay? This one right here, I want to give you a few minutes to see if you can put this together. You have 2 to a power, and you have 1/4. The very first thing you would want to do probably on this problem is write this as 1 over 2 to the second. Now then see if you can do that without using logarithms. Because what your goal is to get 2 to a power equals 2 to a power, then set the exponents equal to each other. Okay? So you want to see if you can do that without logs, and then do 13 with logs. Use like an ln on that, okay? All right, everybody know what I'm trying to get you to do on 12? I see puzzled looks. Okay, that's what I'm asking. Okay, you want to have 2 to a power equals 2 to a power. Well, right now we have 1 over 2 to a power. What can you do with 1 over 2 to the second? Bring it to the top. And when you bring it to the top, what do you get? Okay, that's what some of you are puzzled about. Then you can go ahead and finish it from there. Okay, so what equation would you solve? The bases are the same. What do you know about the exponents? Same thing. Good. So you're going to solve 7 plus 3x equals negative 2. Okay? All right, I'm going to go ahead and shut this off here and go ahead and see if you can get those two answers. But a problem like number 12, I'd like you to do that without having to use a log. You could use a log, but it's not necessary. when you want to get a decimal answer on the second one, and the thing that's most commonly missed on a problem like this is students don't do something right on their calculator. So I do want you to kind of try that on your calculator, round it to 2 decimals, and we'll see if anybody gets it. All right, we got anything on number 12? That one should have been pretty straightforward. I kind of started you. What'd you get? -3? Okay, you should get -3 on that one. Okay, did anybody get a decimal answer on the second one? I'm just curious.
19.9.
Nope.
I got 0.76.
See, look at this. We got all these different answers. That's what happens. Anybody else? Teacher could be wrong too. I got 1.45. But I usually find students that sometimes just don't do this right on their calculator. They don't enter stuff right in their calculator. Okay. All right. So I'll put these up here and I'll show you kind of what I did here and what you want to be most careful about. So the first one, since I kind of started you off on that, you're basically setting the exponents equal to each other. So you want to do that and solve that equation. So you got down to a point where you had 3x equals -9, so you have x equals -3. All right? Is everybody okay with the first one? Okay, all right. All right, now what I've done on this one then, a couple of the key things, you want to see how far you got with your exact answer. So do the ln of both sides, bring that down in front. So you've got that. Now you want to divide by ln of 4. So you'd have 2x minus 1 equals ln 14 over ln 4, okay? Now, this is where it gets a little messy, so this is sometimes where students mess up. Okay, I'm going to move the 1 to that side. I'm adding 1 to both sides, so I now have 1 plus ln 14 over ln 4. Now you're dividing by 2. Now, to me, instead of dividing by 2 to get a complex fraction, it's better to multiply by a half. That gets rid of the 2, and this right here is an exact answer right there. Now, I did 2 things on this, and let me slide this over here a little bit. That would be one way to write the exact answer is like that, okay? Like that, you could put the half in front, or you could distribute. So a half times 1 is a half, and then if you go straight across, you'd have ln 14 over 2 ln 4. Now, let me ask this. Did anybody get those exact answers? You got the exact answer. Okay, good. Anybody else get the exact answer? Okay. Now, what you want to do there is now you want to put this in your calculator. So the way I did this, and let me show this to you. Sometimes students do better on these problems if they get their calculator out early in the problem, but I do want you to get that exact answer. That's pretty important. So what I'm going to do is I'm going to put this one in the calculator. I'm going to put this form right here. Let's put this one in the calculator. I want to do this one because I want to show you what students do wrong all the time. So you could just put in a half, or you could even put in 0.5. Then it would be plus ln of 14, close parentheses. Then you got to divide by parentheses 2 ln 4. So it's got to go in like that. And if you don't put parentheses around that 2 ln 4, it isn't computing it correctly. That denominator has to be in its own grouping symbol. So if I do that, 1.45. Okay, you got the exact answer, I guess, up here. Did you get the decimal answer?
Yeah,
okay. Okay, good. Okay, anybody else get 1.45? Okay, so here's the thing on that problem then, is you want to know how to get that exact answer. Now, one thing that you could do, sometimes students do better on these problems if they go ahead right here and get your calculator out now and do ln 14 over ln 4 and then solve it from there. I bet if you did that, you wouldn't have the same problem. But you do want to go through and be able to get that exact answer of the problem too. All right, so that's the idea. All right, so you guys got any questions about anything with that? And how that's being solved? Okay. All right, okay. All right, well, let's see. I'm going to do one word problem, and then we're going to finish up here tonight with doing a few problems on a calculator, where sometimes you have to solve equations using technology. Okay, so on this next problem here, this is what we're going to get into next week, is a lot of applications of exponential and logarithmic equations. So what this one is it's given this exponential model. Now let's go ahead and just write that down. So we have a equals 235 e to the 0.044t, like that. All right. All right, now what it's going to say is it says t is years after 1998. Okay, so what it's saying is, when will the population reach 293,000? Okay, and they also said the population was already in thousands. So what this really represents here, this 235, that's really representing 235,000. So you're going to just plug in for A, just the 293 only, okay, because it's in thousands. That's the idea, okay? So what we'll have is 293 is equal to 235 e to the 0.044t, like that. Now that's an exponential equation. I'm starting to mess up a little bit here. Okay, so this is an exponential equation. Now what we've been doing, like on the last problem, you did a log of both sides. Now you want to do an LM because of this, but you don't want to do a log until there's nothing in front of that e. So you got to start by getting rid of that 235. How do you do that? Divide, right? Okay, so you're going to start by dividing. You have to do it that way. You can't take a logarithm until you've accomplished that. Okay, so what we're going to do is divide both sides by 235. Okay, now you could take your calculator and divide 293 by 235. I'm going to leave it alone. I want to try to get you to be able to write the exact answer and use your calculator at the end, if you can. Okay, so now we're ready to take a log of both sides. So we're going to have ln 293 over 235. And then on the right side, we're going to have ln of e to the 0.044t. Okay, and then it's the same idea over and over again. This comes down in front. That's the property of logs we learned tonight. So that would be ln 293 over 235. That's going to be equal to 0.044t, and then ln of e. What's ln of e? 1, okay, you want to get that down to a point where you don't overlook that. I see students overlook that all the time on these problems. ln of e is equal to 1. That's important, okay? So now what you're going to have is, you can just kind of think of that going away. Now all you got to really do is divide by the number that's in front of t. And you'll have a complex fraction, and that's okay, because we're going to go to a calculator anyway on this problem. So then we would be able to get our calculator out, and then we do t, okay? But if you got your calculator, do this along with me to make sure that you're doing this right. I hate to see students miss problems just because they enter stuff wrong on their calculator, but that's part of the learning process too. You want to know how to use grouping symbols. This one's pretty straightforward, unlike the last one. So you would just do ln of 293 and divide by 235. Be sure you close parentheses and then divide by 0.044. And then we'll round that off. So that's, like, for all practical purposes, about 5. All right. Now what this says is, and this is an old problem. I hope I haven't been using this example since 1998. Gosh, it's probably taken out of some old book, maybe 10 years ago or something. So anyway, t is equal to 5. But what you're doing is you're doing 1998 plus 5 years later, so what would that be? That's still in the past, 2003, okay? So that's the idea. So what you would end up doing with that is solving an exponential equation, again, using the logarithms like that, okay? All right, you guys feel okay about what I just did? Okay, all right, exponential equations, you want to kind of get right on your homework over the weekend and get that down. So I'm going to finish up tonight with a couple of problems that we want to do on the calculator. So you want to get your calculator out. These problems right here would be too difficult to do algebraically. Okay, that would just be very difficult to do these. So what we're going to do is I'll show you two ways to do this. I'm going to do one of them one way and the other one the other way. So what I'm going to have you do on this one is in y1, just put in e to the x minus ln x in your calculator, and y2 put 3. So one methodology you can use is just graph the two sides of the equation and then see what happens, kind of see where they intersect. Okay, so we would put in e to the x. You've got to go second ln to get e to the x to come out. Make sure you're out of that exponent. Then you have ln of x like that. Okay, and let's see, the right side is just going to be 3, so we're going to do that. Now what I'm going to do on this is I'm just going to start this in a standard window, and then we'll adjust from there. So a good way to start is just go zoom 6, and zoom 6 just puts you in a standard window. And what you'll end up having is you've got that curve, and you got that curve like that, all right? So it's hard to tell without zooming in how many times that intersects. Very clearly it intersects there. It may or may not intersect there, I don't know. Okay, so what I'm going to do is I'm going to do this then. So we're going to do a little zoom. Let's do a zoom box. Have I ever showed you how to do zoom box? If not, it's a kind of a nice feature to learn how to do. So what you do, if you've got this graph, you can press zoom, and then you can do zoom box. And what you do is you try to draw a little rectangle around the area that you're interested in. So what I'm going to do is just kind of get my cursor up kind of there. What I'm going to try to do is just draw a little rectangle around there and zoom in, okay? Because I'm interested how many places this intersects. It may intersect once, it may intersect twice. What you do is you press enter, then you go like with your down key, just kind of go down, and then with your right key. What you have to do is get the vertice of the rectangle and press enter, and then just make sure you got kind of a good box drawn around that like that. And now if you get that, once you get that done, if you press enter, it's going to zoom in just on that box like that. But get your upper corner, press enter, and then proceed from there. Okay, well let's see what we have. I'm going to go ahead and press enter. Okay, and it's just going to zoom on that little piece there. That's the left side of the equation. And there's the right side. So look at that. It went 2 times. I didn't know. Okay, but now I know. So what you're going to do now is you do, to find the intersection points, you have to do this twice. You do second trace. Write this down if you need to. We've done this before though. So you go second trace, and then option 5 is intersect. So you just go down to option 5. And then what will happen is a cursor key will come up, and just move it to where it's pretty close to whatever intersection point you're finding. So you can get pretty close, you press enter. A second curve should come up on the other line. Okay, press enter. Then when it says guess, press enter again, and that'll give you your first intersection point. Okay, so remember we're solving for x, so that first intersection point is x equals 0.16 if we round that, okay, like that. Then what we got to do is we just got to start over again. So what you do is you go second trace, again option 5, and then the cursor this time you need to move the cursor over very close to the other intersection point. Okay, and then once you press enter on that, the other cursor will come up. Okay, so that comes up, press enter again. It says guess, press enter again. You're going to know you're doing it right because it's going to blink on that intersection point. So the second intersection point is x equals 1.14. Okay, so those would be the solutions of that equation like that. Okay, so that's how you do that. All right, look for where things intersect. And sometimes it's good to be able to zoom in to kind of see more clearly where things intersect. That's it. Okay, did everybody follow along on that okay? Okay, the zoom box, did you catch that? Okay, all right. Okay, let's do one other thing. I'm going to do this one a different way, okay, because there's 2 ways you can do these problems. So what I'm going to do on this one is we're going to move everything from the left side to the right side. So we'll have e to the 3x minus x minus 2 equals 0. Okay, and you can do this a little bit different technique. So what you're going to put in your calculator is y1 equals 3 to the x minus x minus 2. So let's wipe off what we have from the last problem, and let's put that in. Okay, and you got two things you need to clear off from the last problem. So what we'll do is in y1 we'll put in e to the x, or e to the 3x. Okay, like that, and then it will be minus x and minus 2. Okay, so you want to get that put in. Now go ahead and do zoom standard. So just go zoom 6, and let's get a standard window, and let me talk about what's different about this problem. Okay, so what we're doing now is, since you've got one side equal to 0, we're looking for the zeros of that function. So you have a 0 there and a 0 there. You're really looking for an x-intercept. So the way that you do this, it's a little bit different. What you do is you go second trace, again, like this. So once you get your picture in there, you go second trace. Then you go to option 2, which is a 0. Okay, and I've shown you how to do this before anyway. So you do this, you do that, press enter. Now it's going to ask for a left bound. So get your cursor a little bit to the left of where that first 0 is. Okay, press enter. Usually a line comes out. Get a right bound, so just go a little bit to the right of where it crosses the x-axis. You'll get a kind of a boundary for that. Press enter. Says guess. Oh, there we go right there. Okay, so what we have is the first 0 is x equals negative 1.997503. Oops. And then we could round that to whatever. I'm just going to write the whatever comes out there. Okay. All right. Then we do it again. So if you didn't catch that, the second time we go second trace, option 2. And then what you want to do is get the cursor a little bit to the left of the other 0, like in there is good. Okay, press enter, line comes out, get a right bound, somewhere in there, just a little bit to the right of it, press enter. Okay, when it says guess, press enter, and the other one will come out. Now you'll know you're right because it's going to say y equals 0. So that's going to give x equals 0.2738205. That's it. That's a different way to do it. You can do all of those problems either way. Okay, so you want to know how to do that with your calculator. Okay, that's important. Okay. All right, everybody okay with what I just did on the calculator then? Okay, all right, so that wraps up today. Go ahead and be sure